So, hard problem, minimum operations to make array elements 0. Queries defines and select two integers, replace them with their floor. All elements of the array to 0 for each query. Return the sum of the results for all queries. Oh, that is a weird ass problem. Looks like that's from a contest, so so I get some queries. They are 10 to 9 and I have to answer each very quickly. So basically, that's weird, bruh. That is weird. That's gonna be some math. Okay, what I'm thinking is I want to count elements in range. Now for numbers 0, 1, 2, 3, 4, we need one operation. For elements 5, 6, blah blah blah. For 16 we need 2 operations, and so on until we get 4 to k plus 1 up to 4 to k plus 1 needs k plus 1 operations. So I guess that's fair. That works. This tells me how much I need to decrease each number, and then we just okay, so now I know how much I can reduce each number by, and well, I have a range, so consecutive numbers will either take the same or plus one more. Okay, and what does that mean for me? Well, I can decrease 2 of them, so because if I can figure this out, if I would just decrease a number, then this would be, I already have the answer. I just count integers in each of these range, in each query and whatever. But since I can decrease 2 at a time, the question is, can I select the same integer? because it doesn't say distinct. Select two integers. But I guess if you are doing simultaneous replacement, you just decrease it by 1. So what I'm thinking about is that in not every operation we can decrease them by 2, because if, for example, we have, I don't know, 1 through 5, then we decrease 1, 2, and then 3, 4. That's 2 operations. Or 4 is already 1 operation. No. Okay, I messed it up a little. Like that. 4, 15, minus 1 takes k minus 1 operations, or k plus 1, whatever. Well, I know how much each number is gonna take. So let's say the numbers will take, I don't know, 2, 2, 3, 3, right? And 3, 3, 3, 3, blah, 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 up to 4. So let's say this is only 2, right? Because if at some range we have even number, I can decrease these 3 times, these 3 times, and these 3 times, and we are done. But since I have 2 here, I first decrease this, right? And then I have to decrease once, decrease twice, decrease once, decrease twice, decrease once, and then I decrease this twice, and then I'm left with 2 here. That is so stupid. Okay, good news is each of these ranges has a even length, so we only care about the edge cases, right? Because it's 4 2 something elements in that, so that's even, because multiplying 2 even numbers gives an even number. So well, how do we pair up the rest? Well, if I go in reverse, right, then I do this, and then 1 down here. How much will it take? 2 plus 1 plus 2 plus 1 plus 2 plus 1 plus 2 plus 2 is equal to 3, 6, 9, 13, and the other way around would include 3 plus 1 plus 2 plus 1 plus, I'm already lost, so this for 3, right, then 1 for this, and then 2 for this, 1 for this, 2 for this, 1 for this, and then I'm kind of stuck here. See, it's this guy. So it's twice, once, twice, and then we got once, twice, plus 1. Wait a minute. that's that. Okay. Okay. That's kind of no, that's not good. Oh, wait a minute, bruh. Wait a minute. 2, 2. So that is 2 operations, 1 operation. 2 operations, 1 operation, 2 operation. 1 operation, 3 operations. So in total this gives what? 3, 6, 9, 12 only operations. So it's better to do it in the reverse order. Well, let's say we would have like a bunch of 3s and then bunch of 4s and then a 5. What if I have a bunch of 5s? Well, I only care about the parity of the 5s. That is true. So shittiest problem ever. This is gonna take 1000 years of edge casing. Now how am I gonna write an explanation for that? Oh my god, bro, hell nah. That feels weird. Well, I'm gonna have to clear this entire thing. Great question. And then I'm gonna have to clear this entire thing by, so it's so late to do this math. Who cares? Let's say I would erase these in 4. If I just erase this in 3, 6, 9, 10, 11, 12, 13, not great. So I really have to calculate this SMH in my head. So this tail I can cut off the even part, right? So okay. What a, oh my days. Okay, so if I cut out everything out of here, and let's say I leave the one element there, why not? Why not? Then I cut everything in here, and I cut this, and I pair these two, right? Then what I essentially did was all these operations, and I also deleted the side two elements, I think. Yeah, that might work, I think. So let's say if I have like a 1, 2, 2, 3, and like that, so I erase this. No, I don't erase it. Let's be here, and then if I erase this and I erase this, I'm left with 1. So okay, if I do that, then I erase these two for 2, and then I erase this for 1 and this for 2, and finally the last one. Okay, so it's gonna take what? All of them except the last two I can erase, right? And then I get a... That's so stupid, bruh. But I can solve it like this, I think. Because then I will have 2 times log 4 of 10 to 9, which is something like 15, 14. So I will have 30 numbers. And how many queries? 10 to 5. That's okay. And then I just remove those numbers, I guess, because I don't want to do math. I think that works. I think it works, but I'm not sure. Let's solve it. That's oh my days. Long runs for auto query in queries, and then I select Q0 and R is Q1. Okay. So my start is this. The ranges are from 1, okay, and they have at least 2 elements. Okay. So I wanna do while Rx is more than this. Okay, so this way I found the okay, so there is a bunch of cases. What I'm looking is at the first segment, which is intersecting. Now there are a few cases. Rx is larger than or equal to R, in which case it is entirely contained. This takes one operation. Let's call it OP. Okay. So I still only care about the vector long resolve. Maybe resolve is not the best word, but I don't know, like to do. It's not even long, they are gonna be ins, but who cares? So okay, so long current ans count is equal to, and now we are gonna do mean of rrx minus l plus 1. Count plus equals power times count, no, current answer. Now if cent percentage 2, then we do cent minus 1, otherwise we do count. Count, okay, it's fair. To do pushback, I don't know. To do pushback power. Okay, and now we do while x is smaller than or equal to r, then we want to do this lx1 plus lx times 4, but that's fair. Okay, power plus plus, and now what we want to do, if lx over r we break, we don't do anything. If we jumped out completely, and otherwise, well, there are two cases. We completely contain the interval, in which case we, so if rx r, then okay, the count is equal to rx lx plus 1 power times count minus 2, and then to do push back power, to do push back power. Otherwise, no, okay. Min RRX, I think that's the thing, and okay. While to do size over 1 long x, to do back, to do pop back long y, to do back, to do pop back. Okay. Swap xy, and then we want to do current ans plus equals y, to do push back x minus y, and then finally we want to do to do 0, I think. I'm not sure this will work at all ever in my life, but fair enough. I hate problems like this, bro. I don't care what David Goggins says. I simply don't like them. Okay, I would piss my pants if it would work immediately. Okay. I'll start by debugging. Wait a minute. I think I'm a little mistaken here, don't you think? Don't you think? Don't you think? Don't you think? Think, 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 think. Okay. Wait a minute. almost got them. Y3 operations. This is interesting. Well, I should kill these, and then I kill these, and I suppose I'm left with this. Well, that sucks. I don't want to do 6 or 2. So that's 2, 3. Maybe like that, maybe like that. Okay. All of them but 2, and then we pull the same scheme as we did here. is weird. How come? So answer after this is 0. Because this 2, 3 and 4 is outside of the range, so first one that coincides, this already does. What's the count? It's this, so that's 3 minus 2 plus 1, that's 2, so that's 0. Fair enough. And then after the first ans b, it's this. So next is 4 to something. So this is the case. This is here. Okay, and then let's just little typey type. Okay, now we are talking. And this probably won't work, but whatever. Okay, give me the wrong test case. Oh, that's a lot of bad answers, to be honest. It's 3, 2, 2. How you do that in 3 operations though? Because this works in 1, 2, 7 works into, what the hell? If I have 3, I can do this in 3 operations. Well, I can do these 2. There is no way. How you do this in 3 operations? You have to divide 6, you get 1, and then again to get 0. There is no way you can do this in 3 operations. What the hell are they talking about? What? How you do that in 3? If I have what? There is no way you can do that in 3 operations. What? Am I stupid? Select 2 integers a and b from there. Well, I can do the 6, 7, 8, right? Then I can either do the first 2, right? And get a 1, 1, 8. And then I can get 0, 0, 8. And then that's clearly 4 operations, right? If I start with 1, 7, 2, oh, If I start with 172, then I do 0, 7, 0, then I am cooked. Oh no, not at all. Okay, so what I did was the first and third, 1, 3, and then I did 2, 3. Wait, all of them take 2. What am I talking about? Man, what am I on? I'm bad at math. It's not a problem for me. Two and 3. This complicates the whole thing absolutely crazily. I should watch a hint. Great, wow, I didn't know that, bruh. Always pair 2 numbers with maximum. Wow, I didn't know that, bro. Thanks for letting me know. Shut the fuck up. Okay, if there is 5 of them, then I can clear these 2 in 2 operations and these 2 in 2 operations. Total sum is 10, so I need at least 5 operations. That's fair. Oh, okay. Okay, that's easier to solve. I think I got it now. So I just store the pairs of how many power, what operations needed. To do push back, count. So I need to do operation, and I have this many of them. And then we do this, and then we do, I don't know, to do push back, operation count of them. Okay. Okay, now this casting loop. Well, I wanna take the two biggest ones ideally. So let's do this. While not to do empty, then we do this auto top one x. Let's call it x. To do back, to do pop back, and now if x count is second, so I remove all of them. So if x, well, depends how many I want to remove. That's how many I move. So long move, no, to move is equal to x second minus 1 percentage 2 x second minus 1, otherwise it's x second, right? This how many I'm moving, so to move divided by 2, right? And then I want to move it to the lower level. And one of them, so now they go to the lower level. So if x first, if it's over 1, no. If it's over, no. If it's over 1, then it goes back, because if it's over 0, it's 1, and okay, so if it's over 1, then we want to add it. So if, why am I solving this? What, who cares? So if after decrease we will still have to do something, then we want to do this. If this is the only number, so if to do empty, then we want to do push back to move. That's how many? No, x first minus 1 to move. Okay, and finally how many need to go there. And now we push one there, else to do back to do size minus 1. Okay, finally I have taken care of the case if x second percentage 2, right? So I have one more operation to do. Then first of all, x plus plus. Second of all, one from the previous one has to move. If not to do empty, then what? Then we want to do back, to do pop back. No, otherwise push back x first minus 1, and how many of them? One, I guess. And now if y is okay, I want to subtract 1 from there. So if there is something, then I wanna subtract 1 from it. Y second if y first. Ah, this is so stupid. I'm gonna lose my streak. What am I doing even? So stupid. Okay, so I'm deep 10 if statements, but that's okay. So what happened is that I have one extra element, and now if there is anything left, then I want to take it out and I want to subtract 1 from it. Now if this is over 1, then I even want to add it back, then I either add it back and then I also have to add this back. Then to do if to do empty to do push back y first minus 1 1 else to do size minus 1 second plus plus, and finally to do push back y first minus 1 so I just push back y. I guess yes, I meant that. What the hell? So first I have 1 is there twice. And I'm not sure how can they really like to do first. So there is to do first, and we just do that, and then we do my days. She's okay. One, two, and 2, 1, and then that's after to do first, and then how did that happen, bro? So I pop this, so I need to move how many elements? So this doesn't concern me. And then this is the case, then we increase the ans, and now if not to do empty, right? We take it out. So that's 1 and 2, and there is one less of them. And if it can still be decreased, wait a minute. Okay, fuck it. Fuck this shit. Even if it's 1. It doesn't matter what this is. What? Fuck's sake. No, 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 no. Why is that? There is 1 here. Okay, almost got it. This is 2 freeze. And then there is... What the fuck? It's kind of weird because I moved this many elements and Why am I doing it like this? K, who cares? I don't know, 4 to 15. Let's guess there is 16. Right, and then to do OP plus equals count. To do OP plus equals count, and then we are gonna do, I don't know, some number of iterations. So while true int k while and to do k if k minus 1 break int j while j to do j if j is minus 1, then ans plus equals means what? There is some number of so minimum of that plus 2 . Okay, let's finish this crap. Well, if there is 2 of them, I mean, to do k divided by 2. Well, if there is one of these, 3 of these, well, so it is this. Let's call this x. That's how many we are gonna decrease by 1. Okay, so to do k otherwise, if we have just k, say I have 5 numbers from 4, then I put decrease all of them except the largest one. But what if what the hell? How did from 2 1 become 1 2? Well, it's 1, so we add 1 to answer, we subtract 1 from here, and then we subtract it from there. worst problem of all time. Trust me. There is 3 numbers that can be turned down. That is not right at all, bruh. Last K is this. Well, 4 to 1 takes 2 operations. Case 16 is correct. Okay. am I outputting anything, or why does it take so long? This is the worst problem ever. Worst problem ever. So I pair up. Okay, so I got it wrong again. I don't actually care about J. So it's just this. I'm sick of this. Well, what this should do is that's how many I take. So 2 problems. So then that takes me 1 operation, and then because then that happens. So okay, worst problem I have ever seen in my life. Worst problem. Wonder what editorial does. Oh my days. N, what's N? Log R. What the fuck? Fair enough, I got that. What? I was doing this from the start. I got to be the stupidest guy of all time. So why am I even doing this approach? I wanna throw up, bro. I wanna throw up. I waste my sleep for this shit. Operation times. Gives the number of non-hour. That's probably because we have to seal. Okay. So I need to get the range. That's minimum of nah, that really shouldn't be free. Okay, maybe we can speed this up. I don't care. Okay, fuck this. Solution. power times size of range. To make 1 to n all numbers in 0, if we can answer the number of operations to make all numbers 0, ans n minus ans n minus 1 plus 1 divided by 2, i.e. the total number of operations required for the range divided by 2 sealed. We just build it from smaller 4 to k minus 1 blocks and block. Note that last block might not fit entirely into 1n, but that does not matter since power times size of rest still holds. That's queries times log of queries times base 2 logarithm of what? Is the number of queries. Memory is O1. Largest number, largest ending number in any query range. Since for each query we do log at most iterations in which we count the operations needed to decrease that range to 0. Okay, I'm going to read the book and sleep, bro, because this is ridiculous.